is a multi-user operating system with multi-programming facility also. And DOS as such is a single user system. So basically our focus is on the convenience, right? So we are expecting that the student, the user should be given the convenience as far as the usage is concerned, right? And then we saw certain list of IO devices and other things, right? In general, we have seen the basics of operating system, and we'll see in detail today what are the things which we should know about this. Okay, so again, coming just to have a confirmation. Are you able to see the shared screen?
Yes.
Just to have a confirmation. Yes. Okay. So let's continue with the chapter which is available in the Peter Gelvin's book. Okay. So that is the first chapter, and what basically it covers is what operating systems do, what is the system organization, the architecture of it, the various data structures which could be used in it, and the various operations. And then the various things which are possible, that are process management, memory management, storage management, protection, and security. We have seen somewhere in the first session what are the basic functionalities of the operating system, right? So those things we will deal it in a separate way. So let us see what things are available with us in this. So the objective of this is to describe the basic organization of computer system. So we know already what is the basic organization. There would be some memory, there would be some CPU, there would be some the system software, the application software, and so on and so forth, right? So we will look into those things and various types of environments which could be available. And as far as the type of operating system is concerned, it's basically into two categories that we have listed in the previous class. One was the copyrighted softwares, right? So licensed softwares which we need to take the permission and then use it, and the other one is in the category of open source, right? So Linux as such falls in the category of open source, and we are happy to have all such type of operating systems now in the mode of GUI also. Earlier those GUIs were not there, right? So we used to have the commands to be typed, and then we need to process everything. So in general, what is an operating system? So a program that acts as an intermediary between a user of a computer and the computer hardware. So it's like an interface between the user and the hardware, right? So I told you in the previous class that if you want to have the printf code, if you want to execute certain hardware for certain functionality, in that case, either you have to write the entire code for the printf so that the appropriate hardware could be used, or you can have certain modules which could be integrated as part of the system calls, and that becomes the part of the kernel, right? And those system calls will always be available with the operating system. It could be any of the operating systems. Certain to use the hardware, you require certain functionalities which will make use of the appropriate hardware in the most efficient manner, and for which there are some certain modules which are provided by almost all the operating systems, right? To open a file, to close a file, to read the content, to write the content, anything that you want to do, for which a specialized modules are available inside the system, inside the operating system, right? And normally we call it as the system calls, and that also resides permanently inside the operating system when it is loaded inside the main memory, right? So otherwise what will happen is you'll have to write the entire code, and for in each of the programs, if there are multiple programs, then you have to write that program multiple times, and it is possible that you might land up into errors while writing the codes and so on and so forth, right? So the objective is to make sure that certain functionalities should be available to the user, so that they can directly use those functionality and make appropriate use of the hardware. So user is basically focusing on the task only, and he should not worry about what things are and how the things are implemented, right? Obviously what things are implemented would be the focus of the user, but then how it is implemented should not be the concern, right? So that's what the work which is done by the operating system, right? And it executes the user program and basically the task, and solves the user's problem in the most easiest manner, right? So it makes the computer systems convenient to use, as well as the hardware has to be utilized in the most efficient manner. So that is the basic responsibility of an operating system, right? In terms of the access to the system, right? However, there is no concrete definition, but then it also works as a system resource manager that we already have encountered. Right. So now this is the slide where we are having the computer system architecture. So we know what is the architecture of the computer system, right? So if you look into the architecture of the computer system, then there is something like hardware, there is something like application software, there are users who are going to use it, and at the same time, no, everything is supposed to be managed by the operating system, right? So hardware, we know these are the basic computing resources like CPU, memory, and IO devices. Right. As far as the operating system is concerned, it controls and coordinates the use of the hardware in the most efficient manner, basically for the application programs, right, and the user programs. Basically, when the user is typing the code and when the user wants to execute any of the program, no, it becomes an application, right? So that application is supposed to be submitted to the system for execution, and then the operating system will take the control and then will make sure that the coordination activities are done inside the hardware, and it will make use of the hardware in the most efficient manner, right? So as far as the application softwares are concerned, no, normally what happens is, no, we use Microsoft Word, we use various types of compilers, we use web browsers, database systems, video games. We do a lot of activities uh, when we are using the system, right? Whether it is desktop, laptop, or mobile devices. No, all of these applications comes into picture, and we are expecting that this should be computed by the system. So who is going to coordinate all these things is basically your operating system. So see, apart from the operating system comes under the category of system software, right? And even the compiler also comes under the category of system software, but the rest of the things will always fall under the category of application programs, right? So wherever when you are playing with the hardware, it is basically done with the help of operating system only. That is nothing but system software. Rest of the things are with the under the category of application softwares or application programs. And normally, the users are going to use it. So who could be the users? Basically, the people who are going to make use of it. The machine, I mean, it could be a robot also, which is going to interact with the system, and some other computers who are maybe interacting or doing some intercommunication, and then submitting the jobs for the execution. So those things could be under the category of the user. So there are various things which we need to see when we look into the computer system architecture. So only architecture only does not mean that there is hardware and that's it. So along with that, there are a couple of other things also, like OS, your application programs, and who are the users who are actually making use of it. Please interrupt me when you are having any doubts. Okay. Next is the components of the operating system. I mean the computer system. So when we see this, the computer hardware comes at the bottom, right? And on the top of the hardware, there will be a system software which is going to come into picture, which is an operating system. So without operating system, you cannot use the hardware, right? So whatsoever your user is there, whoever the user is there, and whatsoever the job is there, if that job is whether a system oriented or an application oriented, if that is supposed to be executed on the computer hardware, then in that case you need to submit it to the operating system. Without operating system, you cannot directly interact with the hardware, right? So operating system plays very important role for execution, almost for everything. Without operating system, your system is useless. Assume, like, if you are I mean, we everyone is having our own body, right? And if there is no brain, then whether that the organs will be functioning properly or not. I mean, hand movement, your eyes movement, and other things may not function properly, right? So operating system, I'm just giving you an analogy for that. So without an operating system, without a proper brain in our human body, no system cannot work properly, right? So similar is the case that if you want to use the hardware properly and efficiently, then no operating system comes into picture. So for various types of applications, various types of requirement, this operating system comes into picture. Now this operating systems are of various types. There also we have seen it could be some of the systems could be for the convenience, some of the systems could be for efficiency purpose, and so on and so forth, right? So I said that DOS is not providing you any convenience, right? Because everything is supposed to be given in the form of commands. So user is supposed to remember everything, right? And based upon the requirement, the jobs could be submitted for execution. Just like when we are typing cc compile cc and the file name, I mean a.out on the Linux platform. So that is a command-driven system which is executed. But if you see Turbo C, Blue Screen, which is normally an IDE, right? Integrated development environment. In that case, what happens is, no, you simply say alter RR and then no things works. You don't have to remember the commands. So, and then no operating system anyway is coming into picture. The operating system is anyway coming into picture. We'll make sure that no the appropriate modules no would be brought into the main memory, will be available there for some time until the execution of the program is not finished. And once it is finished, no, it sends a signal to the operating system that my job is finished, and now you can reply to the onto the screen what is the outcome and so on and forth, right? So in that way, no, certain things are getting executed, but yes, the resources in forms of memory, in terms of the programs and other things would be required to the operating system. So either you can give the commands or either you can have the GUI for that. Both does the same thing. However, no, for the convenience, no, you are having our GUI. Okay. So what does the operating system do? Right. So it depends on the point of view. So at what point, no, what you are looking at, whether you are looking at the performance part, whether you are looking at the ease of use. So anyway, no, we have to make sure that no, the proper resource utilization is done. So user only wants what? User wants convenience. So right. So that is nothing but ease of use, right? And even the good performance at times, right? So both these things are expected by any of the operating systems. So it has to make sure that everything is in the proper manner. So in case if there is some data structure which is getting damaged while executing, then it has to make sure that no, it recovers from that point and will execute your program from where it has left, and will give the convenience to the user that no, you don't have to re-execute your program and so on, right? And as far as the shared computers are concerned, see, there are mainframes or mini computers, no, they are all basically designed for efficiency purpose, but then at the same time, no, it is also responsible. They are also responsible to keep the users happy. Their job should be finished. Ultimately, their job should be finished in some stipulated time frame. Otherwise, again, no, the users will not be happy. So these machines, your mainframe machines, your supercomputers are designed in such, they are more towards the efficiency perspective and not towards the ease of convenience. However, ease is anyway mandatory for certain things that at certain jobs has to be finished in certain times, right? As far as the dedicated systems such as workstations are concerned, they have dedicated resources, but frequently use shared resources from servers. So now recently, if you see certain machines like DGX A100, which is now available from NVIDIA, almost the cost of that machine is somewhere around 1.5 crore, right? So that machine is basically designed for artificial intelligence purpose and with high computational capacity. And what happens is, there are containers which are internally formed. There is memory which is properly utilized in the shared manner, so that each user will get some amount of memory as per their requirement. So that again, there would be some stations, there would be some server which will monitor the job's execution and the resource requirements and so on. And then it will also make sure that the consistent data is maintained for all the executions that we do, right? So mostly these workstations are dedicated for some applications and will have its own resources with itself, and mostly it will be shared for multiple users, and there will be a server which will be responsible for managing everything, right? Next is handheld computers, which are nothing but your mobile devices, which are resource poor. They don't have much sort of resources, but yes, with the help of advanced technologies, we are recently having 8-core processors also available in the mobile devices. So days, what I can say is gone are the days when we say that the mobile devices may not do a lot of computation, but nowadays we are having high-end processors available on the mobile devices also, with a large amount of memory also, which is the 128 GB capacity of memory itself available in somewhere around mobile devices like Samsung S21 and so on, and even Apple also, right? So a lot of new developments have taken place, but yes, when this book was written, it was at that point of time the things would have been different, and recently the scenario has changed, and this even the handheld computers they are optimized for usability and battery life, basically, and they give the best performance as of now with the advanced technologies. So again, it will keep on increasing. It is not that it will be restricted to this much resources only. So resources are also growing with the advancement of VLSI technology, right? And because of that, no multi-core came into existence. And not only, because of that, not only one machine, one CPU, but there are multiple CPUs which are available, which would be available on the machines, and which would be again helping these users for executing their jobs, right? So some computers have little or no user interfaces, such as the other category is embedded systems, right? What I can say is the example of this that would be like washing machine, your AquaGuard systems, water purifiers, and any of the IoT devices that we design. No, that will all come under the category of embedded computers. And if you see automobile, automobile industry is making use of lot of embedded systems, which are dedicated hardware for doing specialized work, right? So wherein there is no interface which is required. So what happens is when you just give the power to the system, right, it starts functioning, and as and when certain threshold activities are performed, those hardwares would be generating certain signals and will be even notifying to the as an outcome, right, to the users, right? So, and again, if required, it will be even stored inside the cloud, and so on and so forth, right? So in that way, the embedded systems are also coming up in a big way with good displays also as of now in the form of LCDs and LEDs and so on, right? So development has taken place almost in all the spectrum, and these are the various areas where what the operating system does and where it is present. That is what this slide is focusing on, right? And any questions? Any questions? If there are no questions, I shall continue. So we have seen that the operating system is nothing but a resource allocator, right? So it allocates the resources, it manages the resources, whatever is available with the system, it first of all analyze that what are the resources which are available with me. So it does its own self-assessment. When you switch on your system, when you give the power to the system, what the operating system does is it collects all the information from the BIOS, right? BIOS records all the information, basic input output services and other things which are there inside the chip, right? So it collects all the information of all the resources which are available, what are the peripherals which are connected to the system, what is the memory available with the system, what is the RAM available with the system, everything it collects everything, and then once the pool is available, it informs the operating system that okay, this is all functioning properly. So once, in case if the RAM is not working properly, let's say, in case if the RAM is not working properly, in that case, what it will do? It will appropriately inform the user who is turning on the computer with the help of certain signals in the form of beeps or so. The long beeps would be there. If the VGA is not functioning, again, the VGA related errors would be notified to the users and so on and so forth. Right? So it first of all see that whatever the resources are there with me, are they functioning properly or not? So if they are functioning properly, then it can continue, and then it will load the bootstrap loader program for loading the entire operating system in the memory. Right. Also, it decides between the conflicts which are possible, basically for the efficiency purpose and the fair resource use. Right. It should not happen that the operating system is, let's say, is allocating one printer to one job, and that printer is, let's say, is fully occupied by one job. Right. In that case, what will happen? So no other users will be allowed to access it. Right. However, in the current operating system, what happens is, in the earlier days when the batch processing was there, this was the situation where one job is submitted to the to do the IO activity, all the other jobs will have to stall. They will keep on waiting till that job is not finished, and it could not be infinity. That time could not be infinity, right? So what happens is all the other jobs will have to wait for longer time. So nowadays what happens is batch processing is no more in use as of now, but yes, the extension of that is also present in some of the systems which are in place, right? So multi-programming and other type of stuff came into existence, right? When one job, if it is taking a lot of time, the other process will be taking the control, and the process will be told that you stop doing your activity, you stop doing whatever you are doing, you give your resource to me. So it manages all the resources, right? And in case if there are multiple users, if they are asking for the same resource, in that case also, no, it has to manage the conflicts. It has to manage the conflict. Let's say if you are opening a file, right, and both this, I mean, multiple users wants to access the same record, right? So we have seen in the database management system that no, atomicity is very important, and only one process should be allowed, or only one job should be allowed to update the record, and other jobs can only read the information. So reading is not an issue as such, right? Reading does not affect the data part, but when you modify your record, no, there is some data which is getting updated, and almost all the users would be affected by that. So conflicting requests has to be managed, and also the resources whatever are used in the fair manner. So there should not be a monopolization of any of the resources. That is very important. I mean, the operating system should not monopolize any of the resources. That is the key word for this. Okay, and operating system is a control program, so it manages everything, right? It has to manage everything in to make sure that everything is proper, right? At any point of time, if the system is going out of order, no, it has to identify that problem. It has to inform to the user that this is the error which is there, so it has to even prevent those errors, right? So in case if the system is going for deadlock is something like a hang situation, right? Your system is getting hanged because of some problem, right? Multiple processes are there. They are asking for one resource, another process is asking for the same resource, but then the first process is not releasing the resource. So in that case, the other jobs will be stalled up, and no, they will not do anything, and they will be keeping on waiting for that resource to be made free, whether it is memory or whether it is IO resources. Okay, so it has to make sure that in case if any resources are of such type, then it has to come out of that situation. It has to come to the safe mode, and from where it can continue, or at least one path should be there, so that it can continue and come out of that particular situation, right? And also if the power goes off, let's say if the power goes off at any point of time, then it has to make sure that the data structure whatever has been updated, that data structure has to be preserved at every point of time, right, in the form of some state in the form of right. So can you hear me?
No, sir, your voice was.
Hello, can you hear me? Just a minute. I think I have opened up. Someone did some mischief there. I will identify who is that, and will take appropriate action for that. Okay. Just a minute. If I can see my meeting options. Just a minute. Huh? Okay, now I think nobody else would be able to do it. Are you able to see my shared screen?
Yes, sir.
Yes, sir.
Are you able to? Okay. So OS is basically responsible for making sure that the programs are properly managed and controlled. In case of any errors, also it has to prevent those errors, and the improper use of computers also should be. Yes.
Sorry for interruption, sir, but someone is removing me again and again. Please, can you take back the accesses?
I think, you should change your password and make sure that now I think nobody will be able to do that. I have changed my permissions here. Only I can present and nobody else. But then, identify who is your friend. I mean, who is doing such type of mischief. Otherwise, I will mark everyone as attendance as absent. Please make sure this. This should not happen again. Whoever is doing, I will record it. I will be able to identify who has done that. Okay. But I would advise that in case if such type of things are happening, you change your passwords and make sure that no, only you can, control your system. Okay. Certain things are not in my hand. You ask her, you should have some, unity amongst yourselves, that so that no such type of things should not happen. Anyway, let us continue. So it has to come to the safe mode, and it has to make sure that no, the systems are properly managed. That is the basic bottom. So that when you go to the system, then you can very easily say operating system is a resource manager. Okay. So no universally accepted definition as of for the operating system, but yes, resource manager. So everything a vendor ships when you order an operating system is a good approximation. So I mean, see, at any point of time when you purchase any of the operating system, so that will be there will be some modules which are going to be made available, right? But it does not mean that it is 100% complete. There is always some updations which are going to be there. There are some security measures which are taken, right? So based upon those things, they periodically update. The designers of the operating system periodically updates the operating systems, and then they provide the patch of that. Right, so we periodically update our operating systems. That normally happens with the mobile devices, right? So we are very frequently seeing that the update of Android is available, so we update it. So in that way, we can say that everything whatever the vendor is shipping, when you order an operating system is a good approximation. It is not the final version. So every time, in 6 months or so, there will be some updates which will be done by the developers, and they will share it with us so that we can have our system up to date. Okay, so that is what is happening. Okay, and one program which is always running inside the computer system is a kernel, right? So kernel is the core. Kernel is the core of the operating system, and on the top of this kernel, our application programs or the system programs would be functioning. So everything else other than the kernel would be what? It would be system programs or an application programs. Right. So kernel basically is what? If I tell you in the simplest way, it would be something like the core modules which are responsible for smooth functioning of the system, right? Of the operating system, which will efficiently make use of the hardware. So your process management, your memory management, your IO management, your file management, your security, all of this stuff, has to be managed by the kernel. So those kernel modules will always be present inside the system at any point of time, right? And your system calls along with that. So basically, any of this, if I say process management, in that case, you have to create a process, you have to schedule a process, you have to open a process, you have to bring it into the main memory, you have to execute that, you have to store the contents to a file. So for each and everything, there are some system calls available, right? And this system calls basically you cannot modify. You can use it, but you cannot modify it. To give you some idea of the previous case, everything a vendor ships when you are ordering an operating system is a good approximation. I would like to emphasize here one point, that when Windows XP came into existence, it was having some restrictions in the sense it was not having that functionality which we are having right now with Windows Vista and other operating systems, Windows 10 and so on, right? What is that difference? Difference is that Windows XP was not able to execute the processes on multi-core systems, right? And what happened is with the hardware was that multi-core computer systems came into existence. So Windows XP, if you try to execute on the current high-end machines, laptops or desktops, your XP the operating system may not be that efficient. It will not make use of those functionalities. It will instead make use of only one core, and rest of the core remains untouched. Right. So the balancing of the load and other things will not be taken care of. So that's why the change of operating system is also required. So down the line, however, see, the operating systems have matured. currently operating systems are at the mature stage, but it does not mean that no, it will remain. On the line, other types of machines which are coming up, high-end machines which are coming up. In that case, no, your operating systems will not be able to use that hardware because those codes were not written at that point of time, even though the patching is done. So there is a continuous updates. There are continuous updates which are done at the back end by the manufacturers. Maybe it is Apple or maybe it is Microsoft or maybe it is Linux domain. So all these designers of the operating systems, they are continuously working to improve upon the performance of the system, right? And user should be given the convenience. So keeping that in mind, it is periodically updated. So where I mean, in which domain, the coding is supposed to be done, right? So for the operating,
Your voice is like cracking.
I would like to that the base that everything is. Can you hear me?
No, sir.
Can you hear me?
Actually, your voice is cracking a lot.
Your voice is breaking.
Oh, okay. Just a minute. Now, is it okay?
Yes, sir.
Okay, just a minute. So what we were discussing was XP was designed to be used on a single core system only. So when we try to use XP on Windows Vista or advanced, the multi-core machines, we will not get that benefit which we were expecting. So that's why the need of newer operating systems came into existence, right? Similar was the case. If you see the operating systems which are available on the mobile devices, there is always a patchwork which is done, and periodically they update the security part and other things, right? So no operating system is, as of now, we can say that it is 100% finished, and there will always be a periodic update which will be there. Okay, so kernel, I was discussing that kernel will always be part of the operating system, and kernel will be basically having the modules. Modules basically for what? For process management, IO management, your memory management, your file management, and the security. So these are the 5 segments wherein the kernel modules would be required to be present at any point of time inside the system. And there would be system calls basically for each of these, and all of these are basically available in the form of C language. That's what I was discussing. Okay. Now is it okay? Can you hear me properly?
Yes.
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 Okay. Thank you. So once, see, what happens is when the system is checking, when you power on the system, what happens is it checks the internal hardware, that whether all the associated hardware inside the system is properly functioning. So if that is functioning properly, it will check whether the keyboard is proper or not. It will check mouse is proper or not, VGA, your memory, your external drives, and all these things, right? So it will check first of all the things which are already present inside the system, they are functioning properly or not. And once it is finding that everything is okay, then it hands over the control to the Bootstrap loader program, which will then be responsible for loading the entire operating system. So initially, it will check for all the aspects of the system, and then it will load the operating system kernel and start the execution. And once the desktop or the screen is available or the command prompt is available, then you can start your execution. User program then can be submitted for execution to the system. Without that, it is not possible. So the idea of Bootstrap program came into existence. So it is basically present inside the ROM or EEPROM, which is there inside the system, right? When you open up your hardware, but luckily, if you have seen your laptops open, there will be one IC on the motherboard, which will be responsible for storing your Bootstrap loader program. And it is like, again, it is an embedded only, right? Initially, it will start from certain location. We'll check whatever is present inside the system with that program. So one by one, all the memory locations of the RAM will be checked, right? It will write something, it will read something, the same thing, right? So, and it will verify whether everything is okay or not. Whatever is written, is it getting the same thing? So entire RAM would be checked, if at any point of time, if any of the memory locations are not responding properly, in that case, it will say that RAM is functioning not properly, right? In that way. Likewise, no, it will check with the interface at the interface level, the drives which are connected, whether it is hard drive or floppy drive or USBs or whatsoever the ports are there. So it will check all the functionalities which are there with the help of that particular program which is residing inside the ROM, right? And it is basically it would be having some sticker on the on that IC. So through that, no, you will be able to identify that this is my BIOS IC, right? And again, no, there could be some issues related to the battery, right? So just to give you some idea, in case if your date is misbehaving, in case if your system date is misbehaving, right? So in that case, what happens is, no, we need to change the battery, and that indicates that no, your timer internally is not functioning properly. And no, by changing that battery, hardly it would be of 100 rupees. By changing that battery, your problem would be resolved, right? So, and that battery basically continuously provides the power to this ROM, right? So BIOS will be always given the power by that particular battery. Okay, and when you actually switch on the system, no, then the battery, I mean, then there is no functionality of the battery. But then when it is in the off mode, no, then also your time is maintained properly. So that time management, no, is also done by that particular battery. Okay, so this was some idea. In case if you forgot your password of the BIOS, then also what we do is we open up the battery and then again reinsert that battery, so that no, your BIOS passwords again would be removed. So it comes to the default mode. It comes to the default mode, and then once you insert the battery again, no, there will be no password. You will be asked to set the passwords of the BIOS and so on and so forth, right? So those were the certain tricks which we used to follow when there is some maintenance of the system. Okay, of the hardware system particularly. Okay. So what I told you that no, inside the BIOS IC there is a bootstrap loader program which is then, I mean, after checking the hardware, no, it loads the operating system kernel into the main memory, and then no, once the things are settled, no, it allows you to go for the execution of the user programs. So whether it is a command, it depends, no, whether it is a command-driven operating system. In that case, there will be prompt, right? In case if it is a GUI, there will be appropriate the first screen, desktop screen, which would be available in the case of Windows and Linux and so on, right? So in that way. So next is your computer system organization. This is anyway covered in the DECO course. So just to, I mean, a glimpse of that. So there are various devices which are there, like mouse, keyboards, printers, monitors, and all such type of stuff, right? And no, there will be some controllers through which those things are controlled. So those controllers and other things also would be part of the operating system. Hello?
Yes, sir.
DECO course or digital electronics or maybe DALD course.
Okay.
Okay, so those type of courses basically used to cover all these basics of computer organization. Or maybe COP was initially the course which we used to teach to our students, but now it is named as DECO, Digital Electronics and Computer Organization. Right, so basically this is a common slide. It is not that, I mean, that to worry. The concept behind it is what I'm telling you here. Just listen to it. Okay, so all this devices basically would be controlled by the controllers, right? So for hard drive, there will be hard drive controllers. Earlier floppy drive was there, so there was floppy drive controller. Mouse was there, so there was the driver for that. Mouse drivers, device drivers, right? So sometimes some external peripheral devices when we connect, for which there will be some device drivers which would be required. Likewise, earlier also, if you see USB, if you pen drive, if you try to insert into the USB, there was some drivers which were required to be installed earlier, right? Nowadays, those drivers are now embedded into the USB itself, but then it has to glue. It has to glue itself with the operating system. Without the operating system, again, you cannot make use of those devices. If you try to do Control-C, Control-V from hard disk to your pen drive, then see, a lot of things comes into picture, right? It has to identify that device. So through, how it will identify that device, at which location it will write the content, what is the capacity of the device, right? Whether sufficient memory is available inside the device or not. All such type of things, it has to calculate. And then if it finds everything, if it is okay, then it will try to go ahead and push the content from one place to the other, right? Either it will copy or either it is move, whatever the situation may be. But the point is, there will be some software. Point is, there is some software which we can say that it is a device driver, which is coming into picture to control or manage that device, right? So all these peripheral devices, whether it is monitor, printer, keyboard, mouse, disk, or any other devices. Now, for each of these, there will be some hardware as well as the software, and that software part will be part of the operating system. And along with that, CPU also. CPU has to be properly utilized, right? So if there is only one CPU, then how to use it? If there are multiple CPU, how to use it? So that all these things, basically comes under the organization part. And the control signals, ultimately the control signals are supposed to be generated by the controller, right? So how to efficiently make use of these resources, and I mean with the minimum time. So basically the maximum time which is taken is with the memory cycles, right? Most of the time is wasted while reading or writing into the memory, right? So how will you reduce that memory cycles? How will you overlap certain operations? If there is some memory operations going on in parallel, can we do the CPU execution at that point of time? All this type of stuff would be the core lookout of the operating system, right? So that was the idea which I wanted to share. But anyway, you know what is disk and mouse and other things, so I'm not going into those details, right? So IO devices and the CPU can execute concurrently. See why this statement is there is because see there is one job which is going to use some memory or maybe auxiliary memory, right? And there could be some other jobs also which could either make use of printer and so on, right? So at the same time, the system cannot go idle. Your CPU cannot sit idle. So CPU, with the help of multi-programming concepts, what it will do is your operating system will schedule another job, and which is CPU hungry, right? There could be two types of processes. One is IO bound processes, another is CPU bound processes. There has to be a mix match of both these types of processes, CPU bound and IO bound inside the operating system. If all the jobs are of IO activity, then there is no use of CPU. All the jobs would be basically for IO activity. So we cannot have all the jobs inside the system which will be which will be requiring only the CPU or only the IO devices. So we have to have a mix match of IO bound as well as CPU bound inside the system. So when a new job is created, the scheduler, there is a process scheduler as such. We'll come to those types of things in the next class. Okay, so the scheduler has to decide whether the job should be permitted to occupy the memory or should be restrained, right? It should not be allowed to come into the CPU at this point of time, inside the memory at this point of time. So that all is under the control of long-term scheduler, right? So those things are should be known to us. So we'll discuss all those things. But the point is that IO devices and CPU can execute concurrently. So CPU is doing something, and IO device also, IO job is also doing something on the backside, in the background. So all this type of things is possible. And each device controller is in charge of the particular device type. So mouse driver, if it is there, then it is responsible for mouse only. Likewise, if there is hard disk, then hard disk controller would be there, which will be responsible to manage that particular resource. So for every device, there will be a device controller, or sometimes we can even say it could be as device driver. So why this controller word is used here is because there could be a possibility that there is a hardware, like the hardware circuitry would be there, right? So that's why you need to devise, first of all, I mean the operating system has to contact the controller of the hardware with the help of operating system, with the help of device drivers, and then it will communicate with that particular device in that way, right? So the idea here to take from this is each device is having its own controller, and additionally, when let's say if you are coming up with your own hardware tomorrow, if you are coming up with your own hardware, then it is your responsibility to provide an interface, that glue code, which will be available for almost all the operating systems, whether it is a Wi-Fi module for mobile device, whether it is a Wi-Fi module, for Android operating system, whether it is a Wi-Fi module for Windows or Wi-Fi module for Unix, right? So in that way. So I mean to say here, what I mean to say here is the designer of the hardware, designer of the peripheral is responsible to provide an intermediate device driver for all the existing operating system. Otherwise, what will happen if you don't provide? Let's say if you don't provide, then your system, your hardware is or your product is not compatible with your operating system, they will not use it. They will simply not use it. So it is our responsibility that if we are designing or coming out with some product, we need to provide an interface for all the operating systems and then periodically update also, right? So that is what is done by almost all the designers of the or developers of the hardwares, right? If you come out with a CD drive or DVD drive, then they are supposed to provide a device driver for that. Device driver which is compatible with the flavors of Unix operating system, flavors of Windows operating system, flavors of the other systems, Android-based systems, in case if it is there, right? So that is what I wanted to tell you here. And it will also have some memory. See, each device controller has a local buffer. So when you try to send any information to the or commands to the device to execute, where it will store? It has to have some memory. Either it is in the form of registers or either it is in the form of dedicated main memory, RAM sort of thing, right? So in that way, it will store the intermediate contents and then it will push it from that particular local buffer to the actual device. So each device may be having some local buffer to store the intermediate data. And next is like CPU moves data to and from the main memory and to and from the local buffer. So CPU directly will not instruct the hardware that you do this. If it is an embedded system, things are different. But if there is an operating system, full-fledged operating system which we are using, in that case, what happens is CPU will be generating some information in the form of commands, right, in the form of addresses basically, and it will inform the main memory that I need this information. So if that information is not present, then from where it has to bring it? It has to bring it from that local buffer, right? So from the local buffer, it will bring it, and into the local buffer also, maybe through the keyboard. Let's say if you are entering certain things from the keyboard will be having its own buffer, and from that buffer, it will be fetched and will be submitted to the CPU for execution. The reverse will also be happening, that if you want to update the information, right, in some cases it is possible, except the keyboard and mouse. We only take the input. From the keyboard, we only take the input. There is no output available in that, right? So depending upon the type of devices which are there, the buffers will be also updated by the CPU. Are you getting me? Hello? So IO is from the device to the local buffer of the controller. So normally what happens is, input is always from the device, right? So whether it is a keyboard or a mouse or something, we will get the input from the device and will store the content into the local buffer of the controller. And then the device controller informs CPU that it has finished this operation once that data is submitted, and will cause an interrupt. So internally what happens is everything internally, even if you click a single mouse and whatever you see on the screen, even if you scroll the mouse, there is an interrupt. If you see the pointer moving, there is an interrupt. If you print anything onto the printer, there is an interrupt. If you type a key from the keyboard, there is an interrupt. So everything internally is managed or is controlled by the help of interrupts only. So an entire operating system basically is interrupt driven. Entire operating system is interrupt driven, right? So interrupt transfers control to the ISR, which is nothing but interrupt service routine, which is always present inside the system, right? So what I would say is there are interrupt numbers, right? Interrupt numbers dedicated for different type of activities, for creating a file, for opening a file, to rename a file, to move a file, right? So all this type of thing, to open a file, to read the content from the file, to write the content to a file, to write the string to a file, to convert your character to a number. For each and everything, there is an interrupt. And particularly when I say that to open a file and close a file and all such type of things, there is a DOS interrupt, which is interrupt 21, which is a universal interrupt, right? So for any of the things which we want to do to open a file and close a file internally, it has to execute an interrupt service routine. It has to execute an interrupt service routine. And there are various ways in which those interrupts could be accessed in the fastest possible manner. But the point is that there will always be an address inside the memory. When it is inside the memory, you have to always refer to it through the address only, right? So it has to reach to that particular place. It has to reach to that particular place, execute that particular instruction, and will then be able to do the operation. So that is nothing but the interrupt service routine. So for every interrupt, no, there are various services. I would say for interrupt 21, there would be an interrupt service routine, right? And this interrupt service routine will be having a lot of services to open a file, to close a file, and lots of things. 255 services are available in each of these interrupts. Certain interrupts may be not having services, may not have services. Like say, let's say what I would say trap, then divide by zero. Right, divide by zero is not having any other service. It is a dedicated interrupt. Right, in case if at any point of time, if the execution turns out to be infinity, right, which cannot be stored inside the register or which cannot be stored inside the memory also, in that case, it will generate the divide by zero error. Right, the divide by zero error is nothing but an interrupt service routine which is getting executed, and the message, whatever is there inside, no, that is displayed. And to display also there is an interrupt. So interrupts are calling another interrupts. Understand? Interrupts internally are calling another interrupts, right? In that way, at certain level, no, it will display certain errors, if any, to the user, so that no, they can rectify the problems. So that's what I was telling you. Interrupt architectures must save the address of the interrupted instruction. So in case if one interrupt is calling another interrupt, and then where it will return after that execution, after the second level of execution. So it has to store the return address. Right, so it will have the push instructions, push and pop instructions, which are there inside the architecture, right? So it will store and those values for returning back, and when the things are finished, no, it will continue from that point where it has left. Okay, so a trap or execution in this is a software generated interrupt caused either by an error or the user request, depending upon the situation. But I would like to tell you here, any system, whether it is an Android operating system, whether it is a Windows operating system or Linux operating system, everything internally is happening with the help of interrupts only. That's why a universal saying that an operating system is an interrupt driven. Any doubts in this? So we'll not go into those things because you might have studied earlier also. This you might have studied earlier also, so we'll not go into those details. We'll stop here. We'll jump into the other type of things in the next class related to the batch operating systems and the types of operating systems, the process management and other stuff. Okay. I think time is up, so let me record your attendance. Where should I go? Just a minute. Huh? I'll stop the recording also. If you are having any doubts, please let me know. Any doubts?